Hi, good evening, guys. Good afternoon. Welcome to the second week of our SQL class. Right, last week we were able to look at the overview RDBL concepts. It told us about RDBM databases. I discussed that we have a lot of vendors, SQL, Oracle, Google. Microsoft, they are the vendors, Microsoft, Oracle, Google, and all that. And I told us about RDBMs. RDBMS means Relational Database Management System. And I told us that we have a lot of them. We have MySQL, we have SQL Server, we have DB2, we have Oracle, we have Progress SQL, and a lot of them, right? And I told us about the syntax, told us about the data types. We have a lot of data types. We have int, big int, small int, we have money, we have small money, we have varchar, we have nchar, that is variable character and character. We have what's it called now? So we have date, we have long date, we have a lot of them, right? So the data types, and we talked about operators. We talked about operators. We have the equal to, right? We have greater than, we have less than, we have less than or equal to, right? These are operators. Alright, and we talked about expression. So when I say the expression, I say okay, when name is Ade, that's an expression, or when salary is greater than 10, when salary is greater than 200, these are expressions. I told us how to create a database by doing the create database, the name of your database, and you click go. How to drop and delete a database, just say drop database, or delete database as well. So you can drop a database, right? And I also showed us how to select database using the use statement, right? So let's say you have a lot of databases. I told us in that case we do a use, for example, different databases that you have, all right? To select it. For example, this is the database we have for now. So I can say, okay, use this database, right? So meaning if I have so many databases, I can specify that this is the database I want to use. All right. So we talked about that. Also, we talked about how you can drop and delete a table. We talked about how you can insert into a table, select a table, a where clause, and an or. How you can update, how you can delete the like clause, the top. Let's say you want to select the top two, how you can use the other by and the group by. So today this week we are going to cover this, right? Distinct keyword, the sorting, constraint, joins, unions, null values, alias, indexes. Alright, and we see how far we can go. Then by tomorrow we'll have a session or a live session, and next week as well we have another live session. Then we start Python. So the next 2 weeks we should be done. All right. So let's get started. So today I'm going to start with this distinct keyword. So from the name, you can see that it means you want distinct, unique values, right? So let me select. So I have a lot of tables. I have quite a number of tables here. So let me see this address table, for example. So sorry. So just say select top 1000. So you can just see uh, top 1000 from that table, right? So if, for example, if you notice as it is, you can see top 1000. So let's say if I say select, you can see city as what's it called now, country region as different, United States repeated, Canada, United States, Canada. So I can use the worst distinct, right? So I can say I can say I can say let me delete this first, let me reduce it. Select distinct. All right, so I can say let's select distinct country region, all right, from this. So first let me do select country region, so you see what I mean. Let me remove this. So if I run this query now, you can see it's writing Canada all the way, but immediately I put distinct, what happens? It just, so these are the distinct country here, Canada, United Kingdom, and all right. So that's how you select. You can do that with all other stuff as well. So I can say select country region. What are the columns there? So I can check the columns here as well. All right. So this is the primary key. Select city, let's say state, province as well. So select distinct region. So I can specify this, all right, comma, city and state, province, state, province from. So if I run this now, you can see that it has selected what country, region, the city, and province. But you can see that we have repeated values, right? The reason is because we've included, so we've included the other columns. So now let's say I remove this bracket here now. So I just say select distinct. Let's run this. So we are still going to get the same result. All right, why are we getting the same results? So this distinct here, so we'll talk about this later. Let me just keep it there. So that's how to use this distinct. So you can say select distinct name from here. So it selects a distinct and unduplicated values, right? So let's look at the next thing, the sorting results. So I think I've discussed this a bit before now. So let me just say select star from this, so that we'll see select star from this table. Let's look at the records. So everything is 450 rows, right? So and we want to sort now. You can see this address ID 91125. So I can just say select and then sort, right? So sorry, I said sort, order by. So that has to sort order by address ID. So the beautiful thing is you have suggestions as you're typing address ID. So I told us if you do ascend, by default it does ascending, but if you want to do descending, you have to put it there DESC, and then you can run your query. So you can see descending, but I want it ascending. I will need to. So this sorts from 911 like that. So yet it is not it's not important, it's not compulsory that you sort with the first column. You can also sort with postal code, right? Or you can sort with the names as well. Let's say you want to sort with the city, sort with city, right? So if I do an execute, you see that the city now starts with A, then B, like that. So you can sort any. So that's that, and you can sort with two or one more than one column, right? So I can say order by city, and then let me say order by address ID, then followed by city. So what this does is first of all it will consider address ID. So address ID is starting from 911. All right, now 911. So if we now have city, for example, you can see border. Now if you now have it has sorted it by address ID first, but let's now say we have this city. Now we now have how do I put it now? So this is starting with B, right? So let's now say this 9 starts with W, and then 11 starts with let's say X. So it will consider the address ID first before it now considers this guy. So because this guy too should be sorted from beginning to the end. You can see it's starting with B here because it considered address ID first before it now considered. But if you say order by this alone, let's try that. Let's try that. Let's remove. Let's just order. You can see Buddha first. Okay, still Buddha say Dallas Phoenix. So that okay. Let me do something. Orders was already and then city. Let's now do city descending. So let's see what we have. So you can still see it's almost still the same thing, but it does work sometimes when we have, for example, this ID have maybe a student name and student ID, and they have repeated names. So this order by two things works, right? So this is just to tell us that we can order by more than one column, right? So we can do descending or ascending. So that's how to sort. That's sorting, right? Yeah, I can sort descending, ascending. All right. So let's proceed. So constraints. So before I let me just I have a short note here for us just to explain constraints. So if you can see this, you see what I said. Constraints are the predefined set of rules and restrictions applied on the tables or columns for restricting unauthorized values to be inserted into the tables. They are responsible for ensuring the columns what data accuracy, integrity and reliability inside the table. Constraint also tell that the data will be inserted into the table when the inserted data satisfy the constraint rule, right? Otherwise, the insert operation will be terminated if the inserted data violate the defined constraints. So what are we saying here is, right, I can say, for example, constraints are, remember in your in what's it called now, in Power BI, I can say I don't want null to be in this column. I want this column to start with 1. For example, I want this column to be my primary key. For example, these are constraints. So I don't want null to be in my table. Remember when I was doing what was it called? When I was doing a design for a table and I said allow null. Look at this now. This one is saying allow null, allow nulls. But this other one is saying don't allow. The one that are not checked are saying don't allow null. So what we are saying is when we are creating a table, we can also set this constraint. So this guy here is a constraint, for example. All right. So these are, so let me just show us the type of constraint we have. So these are the most common constraints used in SQL Server to describe the play. So not null, unique, primary key, foreign key, check, distinct. So these are this check, default. So these are the major constraints we have in SQL, right? So not null, unique, primary key. So unique is just like distinct. So instead of, for example, the query I ran the other time, let me go back there. So the query I ran the other time where I said select distinct. Where I said select distinct, right? So 9, 11, 25 like that. So instead of me running select this thing on city now, instead of me running a query to say select distinct, I can specify when I was creating the table that okay, I want this query to select distinct. Don't select duplicate data, right? So this can be specified when sorry. So this can be stated even from the what's it called now, from your create table statement. So primary key and foreign key as well. You can see if you look at the tables that we have here, this is showing that this pk means primary key, right? You can see keys. You can see pk, primary key is address id. That's it. The name of the primary key is pk address. AK row guide id. So primary key is the address id. So pk means primary key, fk means foreign key, and all that. So you can see anytime you create a table, if you look at the table we created, all right, you can see we didn't specify if we have any primary key here, you can see the constraint, no constraint yet, right? So if you look at this one now, constraint here, it will tell you there are two constraints: the address modified date and the address row guide as a row guide IDs, right? Are there indexes? Yes, there are indexes and all that. So, but in the table we created last week, for example, we don't have any primary key, you can see. So, but when we are creating a table, we can denote primary keys as well. We can trade if it is foreign key. We can check and we can say, okay, this we want this default value, right? Let's say if there is no value indicated, we can say, okay, make this value default. So we'll check that very quickly. Let's go back to our SQL. Now let's create a table and set this constraint. So I can say create table. Let's say the table name is Eagles training or e-training, e-train. All right, I can open my bracket and say I want name. So I want, let's say, std student id, student id. I want it to be int and I want it not null. So not null that is written here is what? A constraint. Right? I'm saying id must not be null. So whenever anytime you come here to check design, right, it will not, so it will not, let's say this is our id, it will not check this, right, because it will now allow null. So let's create that table. You see I'm trying to say now. So not null. All right, so that's, and then I can also set another. I can say this one is what? My primary key. All right, comma. All right, so I've said it's my primary key, right? So that's a constraint, another constraint. Name is varchar, let's say 50, and then age is int, right? Let's say age is int, and then we are done with our query. Now we've created two constraints here: not null and primary key. All right, not null is the student id cannot be null, and it's the primary key. The name is varchar 50 and then int. So let's create this. So it has been created. Let's refresh our tables and then we see it here now. So we have it e-train. So let's check it now. You see that now we now have key, right? You can see pk is pk e-train. That's the name of the primary key, right? And then you can see it has denoted student id as what? Primary key is int and is not null, right? If you look at design, you see that it will uncheck. You can see it has unchecked what? Student id, that it's not null, but other ones have nulls. So this is how to indicate primary keys, right? Then let's look at, let's create another table. All right, so this is one table. Let's duplicate this. So also we can, okay, let me alter this table. For example, let me alter this table. Alter table, alter e-train, sorry, alter table e-train, right? Sorry, I wanted to not alter, so I wanted to update e-train and add. I can add constraint, right? I can add a constraint, right? Add constraint, to let's say age, for example. To age, I can say check. I want to do a check that the age that will be entered is not less than 10. So, oh sorry, check that the age must be what, less than 10. I can add such a constraint like this. All right. Okay, sorry, I think we're supposed to use, let's just use author is a table. So we are working on the table itself. So it should be author table here. It should be author table here. So author table, yes, train add constraints to age, check that the age is not less than 10. This should work now. Is this supposed to be in brackets? Okay. So okay. Yeah. So we're supposed to check. Okay, check that age is less than 10. So let's just, okay, let's do 20. So anytime age, if any age is entered, if you insert value and the age is more than 20, it will throw an error, because we've said, okay, check that the age must not be more than 20, right? So this is how. So if I execute this now, okay, so we just named age, check that age is less than 20. It should work. So not create constraints. Okay. And idea an object name age in the database. Okay, so okay, now what to do? Okay, so let's try it again. It should work. So check that age is not less than 10. Okay, yes, it works now. So we've added a constraint. We've ordered our table. We added constraints. So even if you forgot to add constraints when you are creating, you can still add constraints after we've created the table. So this, whenever I'm inserting values into this table now, if the age is more than 10, it will throw an error, right? So that's how you do a check. And if I want to add a check constraint to my table, it's still the same thing. So it's just that I won't use this add constraint. So let's say I want to, let me duplicate this table, and then let me name it e-test, right? Create table e-test, student ID, not now, primary key, name, and then age int. So I can say check what, check that age is greater than 30, for example. So in this case, I've indicated the check constraint from beginning when I was creating that table, and when I execute this, it says executed. Right. So and if I refresh this, right, so if I go back to the table e-test, you see, right, if I check constraint, it will be there. You can see this is the constraint on the age. So age must be greater than 30. Even the last one I built, that is e-train, because we added that constraint using author table, it's still going to be there. Constraint, you should see the age. You can see our primary key is what, the for e-train student ID. A primary key for this other guy was also a student ID. So this is how to add the primary key check, and then not null. I've also done that. So let's see how to do unique. So you can, if you see this, we are adding two constraints, not null, primary key. So you can add multiple constraints as well, right? So let me create another table called people. All right, student ID is not null, so it's also very good to always just to make it readable. You can do it this way so that to separate it. Now people is my name, so not null, and I can also put another constraint, say unique. That is, there must not be any, so but it's already, the reason why, okay, we wouldn't need both a primary key and unique constraint have been defined for column id people. Only one is allowed. So now the reason why it's throwing this error here is because when you say a primary key by default means there cannot be what? Duplicates. That's the meaning of primary key. So primary key, there cannot be two, so there is no need to create a unique again. Put a unique. So for this name now, I can say, I can put unique. That is, I don't want a repeated name. All right. So unique. Sorry, after that should be after the varchar. So Control V. So I'm saying the name must be what? Unique. That's how you define a unique statement. Any other one there? Okay. So I will. So if you run this now, people, you run this. So completed. Let's refresh our table, and now you will see people. We go to constraint. You now have it's not showing it as constraint, but no problem. Student ID is still you can see you can see PK and then unique, right? So we are saying anytime there is, so if, so let me not insert it, but unique means it must be distinct, right? It's just like using, you can only use unique when you are creating a table, right? You use distinct when you want to use the select statement. That's the difference. But distinct and unique, they mean the same thing in the real sense, right? So now it remains foreign key. Let me talk about foreign key and the default. But before foreign key, let me talk about the default. So I will duplicate this table again to explain what I mean by default. All right, let me name this DDL, right? DDL, it must be not null, it must be primary key. So I want to make it default, right? So let's say I'm inserting it to a table and I didn't specify the age of those people. So default says, okay, let the default age be 10. So I can say default is what? 10. So what this means is, even if I don't specify the age, all right, so I'm creating another table, or let's alter this table. Let's alter this table and insert this default condition, right? So that you can see how that works. So I can say alter table. The table name is EDDL, right? Add constraints. Remember, add constraints, and the constraint is what? The default constraint. Add constraint on what? On age, right? The column name, and then you're adding a default constraint, right? The default is what? You want it to be 10. Alright, so as it is now, we are saying if we insert into that table and there is we didn't insert age, so we are saying it will just give a general age to that table, to that age column as 10, right? Okay, wait. So invalid syntax for definition of table was wrong. Okay. Let me check that. Okay, so the only statement that we need to add for this is we have to specify a name, add constraints. The dfh is the constraint, right? The constraint name, and default is we want 10 to be 10, the age to be 10 for age, right? So we have to specify the name of the constraint. That's the only difference. So let's, okay, yes, it's successful now. So let's refresh this table and check for the constraint. So we should have dfh now. So the age default is 10 for that table, right? So and then lastly, we'll look at primary foreign key. So that will be under constraints. For foreign key, I will create two tables, right? So this table, for example, e-train. So I will just yes, e-train has student ID as the primary key and then the name. Let's now say we have another table is create. Okay, let me use this table, but I'll change the parameters. All right. So let's call this one child. All right. So it now has what it now has ID, not that's its primary key, and then it now has SID. All right, which is like okay, yes, SID, right? Now SID, I can now SID is int, and I'm now making it foreign key. All right. So foreign so I want to know why it's giving the so SID is foreign key. All right, create table eChild in ed int the primary key. All right, SID is a foreign key in that table. So let's create this table now. So what does this mean? We are saying this SID and this student ID, they are the same thing, right? Not the same thing, but we can look up, if you want to do a lookup, we can look up student ID from each child using this foreign key. So that's how you set the foreign key. So let me execute this. I want to know why it's giving. Okay, syntax near. Oh, sorry, int foreign key. So I need to specify the name of the column which this guy is foreign to. So the foreign key is foreign key to student so int. So I need to add references now. Sorry, yes, references references to the table name I'm referencing is e-train, right? Right, references e-train. Sorry, foreign key comes first. References. So foreign key is the student ID. Sorry, foreign key is this SD s underscore ID. All right, and now we are references the e train. Which column from the e train? Students ID. Yeah, we are good now. Yeah. Now create eChild. The ID, first column in that table is ID, is an int, not null is the first constraint, and it's the primary key. Then another column in that same table is SID. SID is a foreign key, so the foreign key, we are stating this table that this table is a foreign key. All right, and it's referencing was the student ID from the e-train table. Student ID from the e-train table. So we can create this now. Yes, so execute. All right, so we can create this now. So if we check, let's refresh tables. All right, so eChild, you can see eChild, you can see keys. Primary key is here, foreign key is also here. If you look at the columns, you can see primary key is the ID, foreign key is what? SID. So SID is a foreign key to by default, what this statement is doing is it has created a it has created so you can see this is the primary key and then this is the foreign key. So that's how that works, right? So that's basically how you set constraints, right? So foreign key, it's a bit different. You have to say this. You have to specify the foreign key itself and then reference the table you're referring to. So if you let me see, if I look at this design now, you can see this is a primary key. It's a foreign. So, but if you come to okay, let me. So tables, yeah, sorry. So if you come to database diagram, you should be seeing database diagram for this. Okay, let's select now database diagram for eChild and what's e-train, right? So let's add eChild and e-train. So close. What can you see here? If you look at this connection, you discover. So, only 1 minute, a few minutes. So if you look at this statement, relationship. Foreign key eChild is SID between e-train. So you can properties. You can right click and look at properties. You can see foreign key. So it's saying this is the primary key here, this is the primary key here, but they are connected using the foreign key SID, right? SID to student ID. I want to see more. Let me see the properties. So you can see identity. So that's this connection is created by default, right? But let's choose different another table that we've done. New database diagram. Let's do customer and eChild, for example. Let's add. Close. what can you see here? You can see that there is no connection here, right? Or you can see there is no connection because there is no, this guy is not a foreign key to anything. So we will have to create that connection ourselves in this case now. But for this, because we specified already that SD is a foreign key, right, to student ID, so it has created that connection. So that's how you specify that, and those are the constraints we have in SQL. Right, let me close all this and let's forge ahead. So that is that. The next thing I'll be discussing now is using joins, right? So using joins is straightforward as well. But before that, before I treat joins, so let me walk us through how. Let me close this. So new query. All right, I want to walk us through how these guys have specified works. For example, I can remember. Let me start with cost. Is there any key? No. So let me go to e child. Okay, e people, right? Columns. This is a primary key. Is there any constraints? No constraints. Let's look for that. EDDL. Is there any constraints? So there is constraint on age. Remember, so we can also look at this to see what that constraint is, right? So you can see what I just did is right click on this script containers, create to new query window. So we are saying this was the author table. We added constraints on the constraint name df age, and the default value for age is 10. So now let's insert values into this table ddl now. So based on this our constraint, let me see ddl. Remember, ddl age must not be where is it again? Age must be what? Default is 10. So if I insert insert into e underscore ddl, right? That's the name of the table, right? Insert into e underscore ddl values. All right, what are the columns under this guy? We have student ID, name and age. So if I insert student ID to be 1, the name to be, remember, is single quote Shegun, right? And I close this, let me say comma another value 2 comma Jide. All right, so let's run this. So by default, you know, it has 3 columns: student ID, name and age. But because, okay, let me do age here, 15. All right, okay, sorry. So yeah, so as it is now, all right, if I run this query, let me run this, does not match the column name or number of supplied values. It matches now, it's just 2. We've created a constraint already. Yes. Okay, wait, let's say 15. Yeah, let me see 13. Yeah, I want to see something, so let's run this. Okay, 2 rows affected, so let's select everything there. Let's see. So it's added, right? Now even if we don't specify, right, you should be able to, it should let me see if I don't specify here. It's throwing error. Okay, so insert into EDDL. So let me the columns are student ID, right? Student ID, comma, name. So let me do it this way. Let me do this way. All right, and let's run this. Okay, so one of what we're saying as so valuation of primary key constraints. So our student ID is primary key and it cannot be null and it cannot be what? It cannot be a duplicate. So we've inserted Segun. Where's that statement? Okay, we've inserted student ID 1 for Segun. We cannot insert another student ID 1 again. So that's why it's throwing this error now here. So it's telling us, you can see it's telling us primary key constraint. So we have to change this guy now to, let's say, 4, and then there's this guy to, let's say, 5. So let's now run it now. EDD educate key value name Segun. Did we okay, I think that in one of our queries, let me see any of those queries that we have here. I think we added unique to name as well for EDDL. Okay, you can see create table EDDL name varchar unique. So we already said the name must also be unique, so we cannot specify Segun twice. You can see now. So these are some of the things you need to know. So if we change this one to Sheg now, and let's say this one to JID, this will run now. You can see it runs. Now let's select up 1000 just to see. You can see now this is running. What is happening? We inserted here, great. So look at the query. Let me close all these guys. Look at where is the query? Oh, yes. So look at this. Insert into DDL student name, student ID and name. We inserted just 4 and Segun, the ID and the names. We didn't insert age. But look at when I ran this query. Let me just say select star, for example. Select star from this table. You can see what we're having. Even though we didn't specify age, it's automatically put a default value of what? 10, because in our query we already added the constraint dfh and the default is 10. That's how that works. You see that? So I think we added one to that checks. Okay, let's look at e-test. We said age, check that the age is not more than what? 30. So e-test is the name of the table, right? So e-test, student ID, the name and age as well. So great. So let's insert into e-test now, for example. Now so we are inserting into just these two, for example, and then okay, let's insert age as well. So it's checking that the age must not be what? Let's check it. The age must be greater than 30. You see that it will throw error now if the age we entered is less than 30. So let's say 25, and let's say this one 35. Right? If you insert into this, look at this. The insert statement conflicted with the check constraint, right? The conflict occurred in database table e-test column age. You can see because this age here is less than 30, so it's checking, and you see that this one is less than 30, so it's saying it is not possible, right? So but if we change this one now to 32, for example, and run this, you can see it now runs fine because it has checked, and it can see now that age is greater than 30 based on this our check here, that check that age is what greater than 30. So this is how to do a check. So and how you can see the application of this is just that, okay, right? You have you want to know, you want to enter a value, but you know that there might be error from you, right? The highest earning person is 30,000 and you don't want that error. All right, let's say for this NYC it must be 30 and you are entering a table that has their salary. You don't want to make mistake. This will throw error, so you know, okay, I made a mistake. That's how you check. Let's look at another constraint. So we checked our primary key. You can see foreign key, we've done that as well. Which other one did we talk about? Unique, we've talked about. Default, I think that should be all, right? Check, yeah, unique, and that's all. So that's how that works, right? So let's take notes of that. um let's proceed. So using joins, right? So I would let me look at the tables we have. So I will use this. Let me insert values into, I think I've inserted value into EDDL, right? Let me select star from EDDL first. Control A, select star from EDDL. Okay, is there any connection between EDDL? Okay, EDDL is the primary key. EDDL has name, student, and age. E-train as well as student ID, name. Okay. Um. Okay, let me create another table. All right. So that represents. Okay, let me leave this. This is student ID 1234, and then name and age. Right. So let me now create a table. Let's say create table. I will run both together so that we can see it. Create table ETTL, right? Enter. Let's now make it ID. ID is int. Let's say it's not null and is the primary key. All right, primary key, comma. Let's say sex varchar. Let's just say it's 10. Comma salary. All right, salary. Salary. Salary is int, or you can even say money. All right, money, comma. We can say check, right? Check that salary is less than or equal to 10,000, for example. We did a check there, comma. Let's now do student ID. Student ID is the foreign key. Student ID, the is int, right? Is a foreign key. All right. So we can even put this as a new line. All right. Foreign key student ID is referencing references. It references what the this table is EDDL, right? EDDL table. And which column is the EDDL table is referencing the student ID from the EDDL table, right? Referencing EDDL. Foreign key references in value table EDDL. There's a table called EDDL, right? Okay, no problem. Let's let's copy this one. So let's create this table. English should work. Why is this true now? Aha, so it's working. So let's insert into this table. Insert into e underscore ttl, right? Values. So one male, male salary is 1000, ID is 2, for example. So 1245. So 125. Let me go to 125. 125 2. So comma. Let me copy this. Just want to duplicate. Control C, Control V, comma, Control V. Let me just change the values. 5 1 100 naira, 400. IDA is 3. IDA is less than 1 2 3 2 3, right? So insert into, we are inserting into this, execute. So 3 rows affected. Now let's select star from e underscore ttl, and also Control A, Control C, Control V. So let's select star from also ddl. So I want to run these two queries together so that I can see, you can see, so I can see both values. So the first one is running for what? E ttl, and the second table here is eddl. You can see if you refresh this, you refresh the tables, you now see ettl, and it will tell you, if you check the constraint, you now have salary as 1. If you check columns, you see a foreign key, student ID, so it's a foreign key. Now these two tables have a column in column, the student ID here and the student ID here. So I can do a join now. So different kind of join. So I will start. So I can join both table based on what? Student ID, right? So I can say select. So I can say select. So let's say I want to join both of them. I want to select name from here, age from here, salary from here, sex from here. So I can say, so but don't forget, name and age is coming from ddl. So select name, age, right, sex. You know, sex is from another table called ettl, right? Sex and salary, right? So it will bring out based on what I joined. So age, name, age, sex, salary from. So you can specify anyone that wants to be our first table. Let's say from e underscore ttl. Then this is where you now specify your join. So we have left join. We have, so when we are saying left join, ettl is the first table, eddl is what? Second table. So if I do a left join, I'm saying return every matching. What is the matching column here? 2 5 and 1. Okay, 2 1 2 5. So it's common there. So what it will do is it will look at this first table first and do a left join. Everything must come from here. So meaning everything from the first table look at the matching columns from the second. So 251 is here, 251 is also here, so it does a left join, right? So let's do a left join. Which table now? We now want to join EDDL. All right, EDDL. Now on, so now ask us on what is the common column there. So the common column here is what? Student ID equals to, where student ID is equal to student ID. Right, that's how you join, right? But now there is an issue. We can't say student ID. We are talking about student ID of ETTL and student ID of what? EDDL. We have to, is either we first of all do what? We will say ETTL dot student here, and then let's say EDDL dot student, so that you understand this. And then all this column too, we have to identify where is the table is coming from. Name and age is coming from EDDL, right? This, which is the second query here. I will say EDDL dot name, right? EDDL dot age, and this one is coming from ETTL. ETTL dot, right, and then ETTL dot, right, and this is fine. So we've identified where those columns are coming from ETTL. Left join EDDL on where, what is the common? This on means we are saying what is the common column, right? What is the common column here? The common column is student ID and student ID, so that's why we do all. But left join is saying consider the left table first. The first table is the left table, so this will work. Another way we can do this, right, is, let me copy this query, Ctrl C, Ctrl V. Instead of specifying the name of the table, right, I can alias, put an alias, like I'm known as Michael. My alias is Ego, right? So I can alias this ETTL as, let's say I want to name it T, and then alias EDDL as D. So anywhere we see ETTL, I can call it T. Anywhere I see EDDL, I can call that table name D. That's alias. So this as means you are aliasing. So instead of using EDDL here, I can just say D. So I can replace all these guys there with what? D. I can replace this one with what? T. I can replace this one with what? T. That is alias, right? So I can now replace this here too with what? T, because I know ETTL is T. I alias it, and this one is D. So this way, this query here and this query here will perform the same function. So let's run it now. So I'm selecting all this. Let's execute. Wow, you can see now. So let me execute these three together so that you see. So look at it now. This is the first table, which is select everything from ETTL, select everything from EDDL, and then this is the join. Alright, so what I did was left join. So left join is saying consider the left table first. If you look at the left table, 251, so Jide, Jid, and Shegun, you can see everything from this first table first. Now take the name, but we don't need we want the name, the age. So it will take the name from here, the age from here, and sex from that table itself, male, and salary from that first table as well. So that is left join, meaning consider the first table first. If I run this query as well, it will give me that same answer. You can see it is still the same answer. Alright, let me run this tree again. So that is left join. So we have left join, right join, inner join, and full join. So we talk about the four. Left join, left join, inner join, right join, and full join. So when you say left join, inner join, right join, full join, so you can sometimes you might be see left outer join, right outer join is still the same thing, right? So and when you just when you indicate just join, join means inner join. If you didn't put any left or inner or right or full, it will do a join. If you just write join, so in case here now, instead of doing a left join, if I do a join, it will do inner join for me, right? So sorry. So those are the four types of join: left join or left outer join, right join or right outer join, full join or full outer join, inner join. So we just did left join. So let me change this query now to right join and you see the output. So what is this going to bring for us? It will consider everything here first. So it will consider all the names here: Segun, Jide, Sheg, Jid, right? And the name, age, 15, everything will be out. But now wherever there is nothing, what is not common to both of them now? 4 is not common to both of them. So in this case now, when it's listing sex, right? Because ID 4 is not ID, student ID 4 is not common to both. So for sex, it will put null for ID 4. And then for salary, it will put null because it's not common to both. That is meaning we are considering EDDL table first, and then we are joining it to ETTL. So let's run this now. You can see now. Look at it now. You can see for Sheg with ID, Sheg is with ID what? Student ID 4, right? Is not common to both. So but it will still return everything from right. That is why it's called right outer. Consider everything from right first. So Segun, Jid, you can see Sheg and Jid. Then it will now look at, so because this is the main table here, name and age, it will return everything here first. Sex from here, okay, I can see 2, I can see 5, I can see 1, right? 2, 5. So if to say I return the ID now, it will be clearer to you. Let me return, let me join, let me add ID onto C, onto V. Let me add ID now. Student ID. Alright, so let me run this now so that I just wanted to see something. So you can see now 1, 2, 4, 5. So 1, 2, and 5 is what is common between both, but it will still return everything. You can still look at this table. 1, 2, 4, 5 is returning everything. The only thing, this sex and salary is from another table. Do not look based on this other ID. It's just 2, 5, 1, 2, 5, and 1. So for Segun that has ID 4, it will say null. That is right outer join. Then the next one, inner join. I can either put join or I write inner join. It's the same thing. So inner join is saying look at what is common to both. What is common to both is what? 1, 2, 5, 2, 5, 1. We are both common to both. So it will return the intersect. So what is common to both? So meaning it will return just 3 records. You can see now 2, 5, 1. You can see it's returning what is common to both, right? And then full join, right? When you say full join is, right, we are saying return everything. So it will return 1, 2, 5, 4 and 2, 5, 1. Let's say this table has another column, let's say 3. You know, 3 is not here, 3 is here, 3 is not here, 4 is here, 4 is not here, but it will return everything together. It will now return ID. So when I do a full join, it will return 2, 5, 4, 3. I'm just saying, for example, if you have student ID 3 here, for example, to return 2, 5. Okay, let me insert into this ETTL. insert into ETTL values so that I can see ETTL is having so values ID ZETTL that has, let me check. Yes, ETTL salary. So okay, ID. Let's say ID. Let me check that again. ID 4 sex female, for example, female, comma, salary 250, comma, and then student ID. I want to add 3 now, right? Let's execute. Foreign key. Why is it returning foreign key constraint? Okay, salary. What's the constraint on this salary? So script as, I want to script as create to, let's look at the constraint. Check that salary is less than or equal to 10,000. Alright, it's fine. This is also less than, let's do 2005. For ETTL, we don't have where is that query? This is ETTL now. Let me see that again. 4 female, yes, 3. Okay, let me remove this constraint first so I can delete. Let's check. Let's remove that constraint first and insert our value. Yes, foreign. Okay, it's a foreign key issue. So let's remove this foreign key. Let's delete this foreign key. So you can delete foreign key, right? Let's modify. You can't even modify. Why is not? Why is it not? You know what? Let's drop the constraint, right? Alter table ETTL drop constraint. So I've copied the name of this constraint. Alright, let's drop it. So we have dropped it now. If we refresh this now, let's refresh. So you can see that constraint is no longer there. So let's execute now. Let's execute this guy. Let's change it back. I wanted to insert 3. So it's done now. So I think that constraint is causing a lot of issue. So we've dropped that constraint. We don't really need it, right? So let me go back to my query. Yeah. So let me do this first. So you can see I've added one more row, which is student ID 3. So if I want to do a full join now, it will return ID 1, 2, 3, 4, 5. So let me select a full join now, and you see. So let me just all this so that you see. So what can you see now? You can see so a full join now. You can see it's returning everything from all. Look at this one, full join student ID, but we said EDDL student ID. That's why it's returning null. So inside this null is representing these 3. You see that the columns that are that we selected, sex and salary, which is female and 2005. You see it here now, female and what, 2005. So this is a full join, everything brought together. So that's that about that. Union clause. So to do that, to illustrate that, I'll look at do table that have similar columns. So this is EDDL, right? So EDDL. So let me just select start from EDDL. This student ID, name and age. So let me look for another table that has that column. I think eTest2, student ID, name and age. So let me confirm if we've inserted anything to eTest. So we want to see how you use. Okay, good. We've inserted into eTest as well. So let me clear this first. So you can see this is eTest, this is EDDL. eTest is the first table. EDDL, they have the same number of columns. So that's to tell you that when you want to do a union on a table, right, it has to have the same number of columns. Very key. And their data types must also be the same. So we just want to union this together now. So I will copy these 2 tables. So union is just to append 2 tables over themselves. So let me do a union now. You just say union. So but we have 2. Now union, in this case, union will do what? We append both table on each other, but it will select unique values from both. So say for example, if I do a union on these 2 tables now, you can see student ID 4 is common to both. You can see ID 4 is common to both. So in this case, but the records are not the same. It's just 4 sheg and 10. So if to say this one also has 4 sheg and the age is 10, you to remove this one of the rows and pick a unique. But for union all, we just do everything together, but union will pick unique value. So let me run all these queries together so you see. So as you can see now, it has added 1, 2, 4, 5, 4, 5. You can see 4, 5, 1, 2, 4, 5. It has added everything together. That is union all. But union will still return the same answer because there is no duplicate value all through here. So if you say here instead of 35 or instead of 32 here, if you still have 10, which makes this row here, row 3 under EDDL and row 1 under eTest the same, it will return just one of them. It will return both. So let's do union all. It will still return the same thing. You can see 1, 2, 4, 1, okay, 4, 5. So 4, 5, 1, 2, 4, 5, 1, 2, 4, 5, 1, 2, 4, 5, and then 4, 5. So it's still returning all. But let's say, So let me alter this table, for example, e-test. So not we are not altering the table now. So remember, alter is used on the table, right? But update is used on a row, right? On columns. So update is used on the column, alter is used on the table. So you want to alter the whole table, that's when you use alter. When you want to update the table, so let's say you want to update this table now to show this 32 now to show 10. What do? You can say update. What is the name of the table? E test, right? Update e test, right? Set age to what? 10, where where age is what? 32. So it will change that 32 to what? This computer. Okay, check. There is on e-test, I think we created a constraint on e-test. Okay, we created a constraint. What is the constraint? How do you view it? You can say script constraint as create to, right? And then new query. So to see it, the constraint is age must be greater than what? Than 30. Okay, so that's a constraint on that. So meaning for this, so meaning our age, where is the query? Where's that query? Okay, so we wanted to update e-test, so meaning we won't be able to update e-test, but EDDL, we can update EDDL. I don't think there's a constraint on EDDL. Let's check if there is no constraint. Okay, there is also a constraint on EDDL. What is the constraint? Let's see it as well. Okay, the constraint is just a default. So default is 10. So it can be more, it can be higher, right? We can delete, we can drop the constraint. Remember, how do you drop? Let's just drop the constraint on this. So let's use this. All right, alter table edd what? EDDL, for example, drop constraint. So you can check what's the name of that constraint you want to drop. Just copy that name, double click, and then Ctrl C. So put the constraint name here, Ctrl V. So drop this constraint, highlight it, and run. Right, you drop it now. So if you refresh now, you won't see this constraint here any longer. So we can now come back to our main query and say, here's the main query. Let's close these guys here. So that, okay, so we can now say update EDDL, set age. So let's first of all select, okay, this is EDDL, right? So we want to make this one look like, let's look at this guy again, 32 here, right? And then EDDL check is 10, check is 10. So set age to be what? 32, where age is what? 10, from that EDDL table. So let's first of all update this. All right, so we've updated that, right? So now let's remove this and then run these two queries first. Let's see, so that we'll see. Okay, you can see now that 4 sheg and 32, 4 sheg and 32, 5 gid and 35, 5 gid and 32. So there is a common row here now, 4 sheg and 32, 4 sheg and 32. So if I use union all, if I run these three now, union all will return how many? 6 rows, right? You can see 1 2 3 4 5 6. But if I use union, right, it will remove, because 4 sheg and 32 is common to both tables, right? There is a common row. It will remove that. It will remove just 1 and return 1. So instead of returning 6, it will return 5 now. So let's try. You can see it's now returning 5. It's picking just 1 4 sheg and 32. That's how union works in SQL. Not values. So This is just, so I think I've talked about alias, right? I've talked about alias. So for example, when we're doing join, right? So let's even do a join on these guys, and I talk about alias as well. So I can, let's say, okay, let me do that on this guy instead of this. So I can say sum of age, right, from our let me see, test, sorry, why is this selecting? So test, so I can say sum the age from this test table, for example. So you can see now, if I run it now, it will sum age. You can see 67, but what is this? No column name. So aliasing, I can use alias to say as age sum, right? As age sum, which means if I now execute it now, you can see it has named it age sum. As, so that's aliasing. Or like I said, maybe you want to do a join. Let's do a Control Z. So let's say you want to join this. Let's run this two table. What is common to both of them? Student ID is common to both of them, right? Let's say we want to say name age, right? Let's just do select star, but we can just say select name from test. Let's do a full join, or let's just do left join. So meaning it consider this first table, the test first. Left join what underscore ddl home. Remember, the common columns are student ID equals to what? Student ID. Remember, I told us I can alias this as, let's say, T, and alias this as what? As D. So in this case now, I will now put the alias in front, D dot. So I'm saying, sorry, depending on the one I want to return. So let's say I'm doing D. Let's do D too. So the names from here, so as D, and then I'll put the alias here, D dot, and then T dot. Execute, and you can see I did a left join, meaning I consider this table first. You can see that the name is D, but it's returning the name from this guy, right? Sheg and Jid, right? Because I've used alias, right? So that's how alias works in SQL. Now the next in the next video, I'll be talking about the rest, indexes, alter table. I think we've discussed about alter table. We discovered how to truncate tables. So I will look at using views, clause, transactions, wildcard, operators, and all. I think this is a nice place to stop for now. Till we see in the next video, right? See you. Bye.